So we have this really bad underestimate and this really bad overestimate. We don't think the answer is 0, and we don't think the answer is 7. Well, the remarkable thing, it turns out, is these two really bad estimates are all you need to get a better answer over and over. Remember, calculus is studying not things we can compute directly, but things that we can estimate better and better. How do we change that bad estimate into a good estimate? Well, the answer is, think about this function v of t is t squared from 0 to 3, and cut that into smaller pieces. Instead of saying it was going at most this fast over the entire 3 seconds, I want to cut the time into 3 1-second chunks and ask how fast was the fly traveling on each of these seconds. Between t equals 0 to 1, v of t goes from, what's v of 0? V of 0 was 0, to v of 1 is 1. From t equals 1 to 2, v of t goes from, well, what's v of 1? It's 1. To what's v of 2? It's 2 squared is 4. Remember, our function is v of t equals t squared. And from t equals 2 to 3, the speed of the fly goes from v of 2 is 4 to v of 3 is 9. So over the course of this 1 second, over the first second, the minimum speed was 0. Oh, I wrote 1, but it should have been 0 here. And our maximum speed is 1. Over the second second, I'm hilarious. Over the second second, the speed goes from 1 foot per second to 4 feet per second. And over the third second, it goes from 4 to 9. So this gives us 3 new different minimum estimates and 3 new different maximum estimates. For the first second, the minimum distance traveled is, if we went a speed of 0 feet per second, times, now we're multiplying by 1 second, because this is a 1 second time period we're estimating, is 0 feet total. And over the second second, the minimum distance possible is, if we went 1 foot per second, for that middle 1 second, we would travel a distance of 1 foot. And over the third second, the minimum possible is 4 feet per second for 1 second. Is 4 feet. So we went a minimum distance our minimum possible distance traveled is 0 plus 1 plus 4 is 5 feet. And our maximum possible, we get the same way by using what was the maximum speed over each of those 3 seconds. We have 1 foot per second for 1 second, plus 4 feet per second for 1 second, plus 9 feet per second for 1 second. This is 1 plus 4 plus 9 is 14 feet. So the total distance traveled is somewhere between 5 feet and 14 feet. What was our original estimate? Our first estimate was it's somewhere between 0 feet and 27 feet. What's our new estimate? Our new estimate is that it's somewhere between 5 feet and 14 feet. On the one hand, this is still not a great estimate. There's a giant gap. Like the distance between 5 and 14 is massive. But instead of focusing on that, focus on we have a trick for making our estimates better. And just like with derivatives, when we do the difference quotient, we never get the answer, but we can get closer and closer. We can take this idea and push it farther. This time we cut the time up into 3 1-second long chunks. What happens if we cut the time into, let's cut it 6 chunks of half a second each? What would that look like? So we cut our 3-second time period into 6 pieces. Each piece will be half a second each. And I think about what is the maximum and minimum speed over each of these half seconds. From time equals 0 to 0.5, our function is increasing for the whole time. It's nice to have a function where we understand that. Over this first half second, the slowest that it went during that half second was the time speed at the start. 0 squared is 0. What's the fastest that the fly went during that half second? Well, the speed at the end is the biggest. It's an increasing function. V of 1/2 is 0.25 feet per second. During that first half second, the fly moved from a starting speed of 0 feet per second to an ending speed of 0.25 feet per second. What was going on let's jump to the 5th half second. In the 5th half second, that's from time 2 to 2.5. The slowest that the fly went was 4 feet per second, with the speed at the start. The fastest that the fly went was 6.25 feet per second, was the time at the end of that 1/2 second chunk. And from each of these computations, we can jump to what's the minimum distance traveled? Or the minimum possible distance traveled. And what's the max possible? How would we work these out? Well, the minimum possible distance traveled, let's jump to the 3rd half second. If you went 1 feet per second for that entire half second, the first time we multiplied by 3, then the second time we multiplied by 1. The thing we're multiplying by this is half a second going at a minimum speed of 1 foot per second is 0.5 feet. What's the maximum we could have gone? Well, our maximum speed during this half second was 2.25 feet per second. If we were going that fastest speed for the entire half second, we would multiply that by 1/2 a second and get, 1.125? So we do that for all of these intervals. For each of our half-second time periods, we've written down what the minimum speed and the maximum speed was in feet per second. We multiply each of those by half a second. We're multiplying by the same thing every time. That's kind of convenient. And we get an answer for this is the smallest amount of time that the thing could have traveled over the course of that half second. And on the right-hand column, we have this is the largest amount of distance that the bug could have traveled in that half second. So now we want to add up these columns. Adding up all the minimum distance traveled over all of those half seconds will give us the bug traveled a minimum of this distance in the total 3 seconds. Adding up the maximums will give us the maximum it could have traveled. So here I've added up all these minimum possible distances traveled, and I'm getting 6.875. And it'll be valuable to notice that this list of numbers using the minimums is almost the same as this list of numbers that uses the maximums. Like this matches this, this matches this, this matches this, this matches this. The only difference is the first one's different and the last one's different. Well, here our first one was a 0. I don't have to accommodate that. Oh, don't go away. The second one is all the exact same, but with an extra 4.5. So let me add that 4.5 on. And we get the maximum distance it could have traveled is 11.375. So our minimum possible distance for our fly to have traveled is now just under 7 feet. And our maximum possible distance the fly could have traveled is now this, which is just over 11 feet, we have another slightly better estimate.